Hello. Today, we will discuss bending stress strain. Factors causing strain in a superconductor include magnetic, thermal, winding, and bending. Today, we will focus on stress strain due to bending, while the other factors are addressed in Chapter 3.2.1, Chapter 3.2.2, and Chapter 3.2.3. Firstly, the definition of bending is a phenomenon that occurs when a slender structure is subjected to force perpendicular to the longitudinal axis of the structure. As shown in the diagram on the right, when bending occurs, the upper part of the structure experiences compressive stress, while the lower part experiences tensile stress. At the same time, a section within the structure experiences no stress, known as the neutral axis. Next, let's examine the bending strain of an isotropic bar. Let's consider bending a bar, as shown in the diagram on the left, to the shape depicted on the right. The outer part of the bar experiences tensile strain, while the inner part experiences compressive strain. The maximum and average values of these strains can be calculated as follows. Next, I will discuss the bending strain of high-temperature superconductors, HTS, composed of single-filament and multi-filament structures. These two HTS have differences due to their structural variances. An example of a single-filament HTS is REBCO, which is produced through epitaxy. In this process, the stabilizing layer, copper, is deposited with the same thickness above and below. Hence, the thickness of copper does not affect the bending strain acting on the neutral axis and the superconductor. An example of a multi-filament HTS is Bi2223. Unlike REBCO, Bi2223 has multiple filaments, causing each filament to experience different strains. Therefore, the multi-filament structure of Bi2223 can reduce the effective bending strain. The table below calculates the maximum bending strain on the superconductor when D, as determined from the equation on the previous page, changes. In summary, bending is what happens to a slender structural element when an external load is applied perpendicularly to its longitudinal axis. Bending stress strain refers to the forces and deformations a material goes through when it's subjected to bending loads. The neutral axis is an imaginary line within a bent material where there's no tensile or compressive stress. In a beam, direct compressive stress occurs in the upper region, while direct tensile stress happens in the lower region. That concludes our presentation on bending stress strain. Thank you for your attention.